Alright, so here we've got a Hess law problem. And the target reaction is this one, A gives C plus F. So what you need to do is look at each of these reactions individually. And the first thing I would do is determine if everything's on the correct side. But when I look at this, I look for A, and I see A is here, but it's on the incorrect side. So I know I'm going to have to flip the first one. So I'm going to go ahead and do that. A plus 2B gives C plus H. But if I do that, delta H is going to flip as well. So that'll be negative 233 kilojoules per mole. I was right, kilojoules per mole up here for all of them. The next one, we've got C. Let's see, is C on the correct side? Well, C is on the correct side now. When I flipped 1, now C is on the correct side, so that's good. Let's look at F. Now F is on the correct side. It's over here, but it says half F. So what I'm going to do is I'm going to take that 1 and I'm going to multiply it by 2. So that would be 2G gives F plus 2B plus 2D. Now the delta H there is going to be 2 times 194 kilojoules per mole. Then we have to figure out what to do with this third reaction. As you can see, there's nothing in the third reaction that's actually in the final reaction. But we can see that if we were to leave it the way it was, that the G's wouldn't cancel. So if I do switch this around, so I'm going to flip 3. And I flipped 1 as well. Then what's going to happen is I'm going to end up with H plus 2D gives 2G. Now you can see what happens is that the 2G's will end up cancelling, which is what we want. The H's end up cancelling as well. The 2D's end up cancelling, and the 2B's end up cancelling. So all we're left with is A gives C plus F, which happens to be our reaction. Now this one here, I did mean to do the delta H. The delta H is going to be minus 152 because that ends up getting flipped around as well. So we change the sign. So the delta H for the reaction will be all of these added together, and I'll leave you to do the math on that.